Hi there. In this video, I'm going to chat with Jason Bonninger and Huiqi Zhou, my friends and colleagues, about the open-closed principle. In particular, we're going to be discussing a paper by Robert Martin called the open-closed principle, and it was published in the C++ report. If you want to follow along and read this paper yourself, I recommend you go to the Wikipedia article for the open-closed principle and then jump to the second reference in this list and click into here. And there you can read this paper for yourself and decide for yourself what your opinions are. Without further ado, enjoy our conversation. Huiqi and I, we had a couple of conversations about this topic. And the last time we kind of left off with, hey, what can we do about leaky abstractions if it is a problem? And then we went in the direction of, hey, there's this thing called the open-closed principle. And I think that would be a good thing to talk about because it is an approach that is trying to address some of the issues of leaky abstractions. But before we start, I kind of want to get Jason's thoughts about this concept of leaky abstractions. What are your thoughts about it? What do you think it means for us as developers?
I really like the article. I think it's like a great problem statement because it's very real. Like the HTTP issue definitely strikes home where we don't understand a lot of what's happening and it's pretty crazy, but most of the time it just kind of magically works. And that's really great to be able to trust that. Yeah, I really liked it. I think it is one of the fundamental challenges of writing software that you just don't really get away from. Like you don't learn out of it. It's just something that we always have to deal with and decide how best to compromise on. And that I think is like kind of what makes us a good or not good developer, because you're always having to do it.
So let's dig into this paper by Bob Martin called the open-closed principle. So at software entities, classes, modules, functions, etc., should be open for extension but closed for modification. First read this. I don't know if I ever got Bob's book, but I read about his solid principles, and this is one of his 5 solid principles. Is the O of the solid, the open-closed principles, and there's 4 others. But this one kind of stood in my mind the most. I like the way that this statement reads. It's like open for extension, but closed for modification. Why do you think this is a good idea, first of all?
For me, it makes me think of like probably an even higher level concept of, when you create any kind of public API, you really ultimately then can't change what you've released publicly, because if you change the way that behavior works, then or remove it, then you break dependencies. You kind of have to design that way, and I think this is like really expounding that. So it makes sense to me.
So like, yeah, you publish an API or you publish a library that other people are gonna download, and if you republish it and break stuff, it could be a problem. From a point of view of your own code base, what would it give you to adopt this within your own private code base? Are there any benefits to using this by yourself?
When I see a Git diff where it's like all green, that usually feels like pretty good in general, because you've added some feature or functionality to your code, but you haven't changed any lines. I mean, in general. And I think, again, that's kind of what this is touting, is if you can make your code base, if you can build it in such a way where you only add to it, but you don't actually change what's there, in theory, you would have a very reliable code base, because you're only adding more and more functionality, but the existing stuff you're not tweaking or changing. So you don't risk introducing bugs.
So what you're pointing to is that when you change existing code, you can break stuff.
Yeah, you don't get that sweat.
So yeah, so like if you see a lot of red, you're modifying a lot of code, so that risks break stuff. And would you just say it's fair that like the motivation for not modifying anything is you just don't want to introduce any breakage?
And I think to be even maybe a little bit more specific about it, like breakage is obviously bad, but also even just a change of behavior. Like maybe it's not throwing an error, or maybe it's even acting relatively correctly, but previously it was doing it this way and now it's doing it just a little bit different. And if any of your dependencies, have made that assumption, then you can obviously mess with them, unintentional or not.
Yeah, to me, I guess I kind of questioning like what does modification mean, because the modification can mean modification of an interface, which, as what Jason said, is like, oh, once you publish the interface, of course you can't change it, otherwise you would break the compatibility. But what if I don't change the public interface, but I just modify it internally for whatever reason? Does that count as this?
It counts as modification by what this article is saying. I'll just read this part that says, when a single change to a program results in a cascade of changes to dependent modules, that program exhibits the undesirable attributes that we have come to associate with bad design.
But if you change the internal of the layer, you wouldn't cascade the change because your interface doesn't change.
That's a good point. He doesn't explicitly say he's avoiding modification because he wants to avoid bugs, actually. And if you saw him say that, please let me know. But I don't think he actually says that. But I still get the feeling that implicitly that's a big part of it. So I'm reading between the lines. But what he points to more specifically is like, well, you change this one thing, then you have to go change that other thing, and then you have to go change that other thing. And yeah, your point about the interface that's sort of what he's proposing. He's saying we can come up with a design where you can extend it, but we don't have to change the internals, basically. And then one way of doing that is by using interfaces as the protocols, where the different components are going to talk to each other, but there are different ways as well.
I want to say two things. The first is this statement made me feel like software development that's different from like other things, like say engineering a car, is software changes so fast. So I think this statement is because we change things so fast. So we need to come up with a way to we can easily adjust to like a change request. That's why we have that. But I feel like the limitation is also always there. It's like, how do you see what is the change request? Because of course you can try your best to predict what the change is, and then you can leave that open. But I feel like you can never predict everything. So there will always be the case that you have to make the modification.
Mm-hmm.
Yeah. That's one dot. And then the second dot is not related to the first dot. The second dot is there is like a popular concern of using libraries versus using like a server, which is like, say, if you use certain code as a library, you have to think more about how the code connect to each other, because say if the library the library got changed, and then your code might have to change. So if you use a piece of code as libraries, then the connection point is much larger than, say, if you just use something as pure service, because the service only have a abstract API. Say if you make an API call to do something, then this interface is relatively small. But sometimes the library, because you are using the code itself, so the interface is I shouldn't say because this interface, it doesn't mean that like interface in terms of coding. So,
You're
but
saying,
the next point is much more complicated. So you have to think more about backward compatibility and things like that. But if it's just calling a service, I don't care how the other end works. Yeah.
Okay. You're basically saying when you bring in a library, you tend to depend on the library more.
Yeah.
That also tells me like the library tends to have a larger surface area in the like the amount that you're touching the library.
Yeah, I have an example.
Yeah.
In my current work situation, so we have an automation testing like team. Those people are using Java, and then each team will also use Java to write your own automation testing for your app. And then this automation testing team will use their Java code to bring my team's Java code as a submodule, which means their code is going to directly call my code. Well, then one day we decided saying, hey, I want to upgrade my Java version to a higher Java version, and then it break, and their code can never call our Java code anymore unless they modify their code. Yeah. So that is the problem. But if they call us as a service, and then we will run our code on our own end, then they wouldn't care which Java version we're in and things like that.
Okay.
Got it. So that's an example.
There's just more dependencies.
Yeah.
There's more points of failure that you're more intimately dependent on that library, and that tends to happen more with code libraries than API calls.
Yeah.
Although there are code libraries that have a small surface area as well. I would say like if you just bring in a library that generates UUIDs for you, that's a very small surface area for a library. So it's dependent on what the library is trying to do or how many features the library is trying to provide for you. Coming back to your first point, we're always going to have new change requests that cause you to have to change something. You can never predict everything that's going to happen. But at the same time, you want to have relative stability, because if everything is unstable, that means you're going to have to change a lot of code all the time to implement any new feature. And that's going to be very costly. So the relative stability is, I think, what this open-closed principle is going for, right? You want stability despite the fast-paced changes in requirement. So basically what we're saying is we're going to give you these extension points with which you can sort of plug in these placeholders, right, for functionality. And this example is like, I have a square or a circle. How to draw a square or how to draw a circle, that depends on what shape it is. How to draw the thing depends on what shape it is. And that's going to be a different piece of code to draw a square versus draw a circle. So what you could do is do a switch statement and see which one it is, and then call the appropriate function. Or you can make the drawing part an extension point that is like a placeholder, and the implementation of the shape, whoever is going to come in and implement the shape, will provide the draw function, which I believe is what the next one is. Yeah, so if you're going to implement the square, you're going to have to provide how to draw the square. If you're going to implement the circle, you're going to have to provide how to draw the circle. And if later on somebody provides a triangle, they would have to provide how to draw the triangle. That's the solution that this article is all about. What do you think? Does it solve our problems? Actually, circle back to what Jason said about earlier. We have this function called draw all shapes, and that function is going to be stable for any new instances of shapes that you add to the code. That you add a triangle, this function doesn't have to change at all. because the triangle is going to provide its own draw method, and that just kind of plugs right into here. To Jason's point, you're just going to see green, right? You're just going to see a file that's all addition relative to the logic that's needed for the triangle, but the existing stuff didn't change. So my question is, does that solve our problem?
I have a thought.
Yeah.
I think it's the main thing that is to me, the opposite of this issue. I guess it's probably going back to leaky abstractions, which is why that's the other subject we're talking about, is that this open-closed principle says, well, if you abstract it, then we never have to change because everybody just implements their draw method. And that's great. And then we just call the draw method. You can implement whatever you want. On the flip side, I think that is actually a huge negative, that you can implement whatever you want. Because even though it would be wonderful if our code was just incredibly modular, only did exactly one thing all the time, and we're always striving for that, oftentimes in reality, the fact is that draw method is going to have to be a lot more complex than just this perfect little unit of I'm going to draw something. And you always have the risk of other developers, perhaps less experienced developers, but perhaps more experienced developers who have a need, doing something around that abstraction that, it works for every shape, but it doesn't work for this one. And that can be a very difficult to track down bug, and also very difficult to manage, because all you've said is you get to execute some code at this time.
I just want to add to Jason's point, which is, how do you draw the line of what kind of code you want to put in the draw all shapes, and what code you want to put in each for each module to take over. For example, if draw has a validation of some sort, you can't draw more than 60 square feet. Where do you put that?
Okay.
Right? All the shapes need to have same validation. Now what? Do you put it in draw all shapes, or do you put it as another interface? Or what do you do in this?
Cam draw.
Yeah. In my UI framework, I actually had to come up with something to solve that problem. And what I came up with is a concept called the region. And basically the region has the job of checking the bounds, checking if you're correctly drawing within the bounds that you're allowed to draw in. And you're going to have to use a method on the region object to draw so that the checking is completely enforced by the region. So the draw method would take a region, and the shape that needs to draw needs to ask the region to draw the thing. But I think the point is, though, when Jason was saying, hey, there might be some special case where this way of specifying the boundaries of what is your responsibility versus what is the engine's responsibility, that scheme may not work out for whatever reason. Developer has to get it working somehow, so they're going to cheat. Like in the draw case, it may be they have, in addition to drawing, they also do something that's a side effect inside the draw method or something weird like that. And then maybe it works for them the first time, but later they found out that causes a bug somewhere. I don't know. Cheating, yeah, can lead to problems. If you ask Bob Martin about this, he would probably say, well, you should introduce another extension point, right? Like your set of extension points is not enough to satisfy the new requirement, and therefore you should probably add a new extension point to satisfy your scenario so that you don't have to cheat. Does that sound right to you, Jason?
So yes, full agreement. Yeah, maybe every shape has a can draw method that returns a Boolean. And so the loop first calls, can I draw this shape? And then if it can, then it draws it. For the example. But like your solution of, well, instead I should actually pass a dependency that helps the shape draw itself into the draw method, is much more elegant and not just spit out in 2 seconds off the cuff. And like, I think that kind of represents the challenges. Like you said, that developer who maybe is less experienced, maybe isn't as familiar with the architecture, like then that challenge is to, like, how do you even know to extend it? And if you are extending it, like if you just throw in a can draw method, now we have this can draw method that everything has to deal with, whereas it would have been far better to implement it a different way. And now you are talking about making a change to everything possibly later because you have to, because this can draw method just isn't doing it. What you really need to do is like pass in a dependency, like you're saying.
I mean, I wouldn't necessarily say like my method is more correct or anything. It depends on situation to situation, and everything is a trade-off. But you're saying if you add a sort of extension point, then all the existing classes have to also add that extension point, and that's a cost.
It becomes a very it's very meaningful changing this interface, which I think is hard to avoid.
It's not just meaningful, it's a cost in that all the existing things have to adhere to the new standard, and all the future things also have to adhere to the standard.
And also, in this case, you introduce a change to the engine as well. You have to put if can draw in the draw all shapes in this case. But if you introduce is Toby's solution, can Toby's solution avoid a change of draw all shapes?
No, because okay, I'm proposing add a parameter to the draw method.
Okay, so you in this case you're still, but you don't have to change the inner implementation of draw all shapes, do you? Or
yeah, you do, because you have to take the region and supply it to all of the calls.
Gotcha.
Toby, I like what you said about it's a cost because it's a cost you're paying now and in the future. And I think we're all pretty good at looking at that now cost, but that future cost is what's scary. Because it's not that your method is right or that can draw method is right or some other method of doing it is right. It's just that whatever you decide, you're gonna then experience.
Yeah, and because of that cost, you're kind of worried. Like, what if I make the wrong call? What if I make this decision? I have to make the decision today because the software is going out on Friday, so I have to make a call right now. But if I make a suboptimal call later on, I'm gonna regret it, and then I want to change it. I want to remove this one and add a different one, maybe. And that's another cost that we're going to have to incur. So it gives you pause to do something like this. If a developer that's not as experienced, that they probably wouldn't even think of extending the protocol. They're not experienced with doing that kind of thing, this higher level design. They're just more used to, adhering to whatever the current standard is. So they're not going to want to do that, and they're just going to try to cheat and somehow implement it with the current standard. Oh, one thing I wanted to mention that Bob did, it should be clear that no significant program can be 100% closed. And what he means by closed is protected from modification. Like he would use the word close in the context of, hey, by adding this extension point, letting you sort of freely extend how to draw any shape you want, I have closed off my draw all shapes method because my draw all shapes will never have to change as long as this current protocol works out. So we've closed the draw all shapes, but then right after that he says it should be clear that no significant program can be 100% closed. So he's saying you always have possible feature requests that causes changes that you did not foresee, so that you still have to change this code because of some of the things we said earlier.
Toby, would you say it's fair in general to say that OpenClosed Principle, the closed piece is focusing like on implementation, But
Yes.
if you're actually talking about architecturally redesigning or adding architectural features to a program, that's what he's kind of talking about. You have to step out of it. You can't just have code that magically doesn't change forever.
I would say this is like, if code can be closed, can be protected from modification, as long as the extension points you came up with all happen to match the future requirement.
Yeah, that's fair.
If you are really good at predicting what variations are going to come to the code in the future, then you can be really good at closing off your program. But all of that depends on the correctness of your prediction.
It depends on whether the change requirement is to add the functionality of draw stuff in order versus like, oh, if I want to change the exact order, which one orders goes first. So that maybe is what Jason said about implementation. But this whole functionality is that like that is the source of changing the engine, because you still have to put the order stuff in the engine when this new requirement comes in.
Since closure cannot be complete, it must be strategic. So the designer must choose the kinds of changes against which to close his design. So yeah, you have to try to predict well. This takes a certain amount of what is this word?
I think that's prescience.
Prescience? What is that?
It's a kind of just another word for like awareness.
Okay.
Awareness, but more of like a future facing awareness.
Okay.
I was to say that.
Yeah, future vision. Yeah, exactly what I was saying. Like you need to be good at predicting the future, derived from experience. Yeah, that's fair. Yeah, I do agree that with more experience, you're more able to predict the future.